So, yep, you can put it in there. I already have it on, so you don't have to do anything with it.
Okay.
And you're good to go. Good luck.
All right, thanks. All right, I think we'll go ahead and get started. I think there's a few more folks at the reception who are going to filter in, but I'm try to go ahead and stay on time. So I apologize, first of all, for my voice. I'm losing my voice a little bit, but I'll try to power through this introduction. I'm Sanjay Raman. I'm Associate Vice President for the National Capital Region. I'm a professor in electrical and computer engineering, and I'm also the President and CEO of the Virginia Tech Applied Research Corporation. So I'd like to welcome you all to our first Science, Technology, Innovation, and Policy lecture for the 2018-2019 academic year. Really appreciate everybody coming. As you know, we do 4, 5, 6 of these a year that try to engage our faculty and students with very high-level speakers from industry, academia, and government on topics that are of interest to our National Capital Region research community. So I'm very excited to have a great friend and a leader in science and engineering and national security, Dr. John Zolper, join us today for our first lecture. So John is the Vice President for Research and Innovation at Raytheon. He partners with the Chief Technology Officer at the corporation to develop and implement integrated technology and research vision and strategy for Raytheon. Prior to joining Raytheon, he's had a long and distinguished career at DARPA, the Defense Advanced Research Project Agency. A little inside scoop, John was the office director in the Microsystems Technology Office who hired me, so any Any mistakes I made are his fault. So, but he, as the director of MTO, he oversaw a close to $400 million research portfolio per year in a wide range of technologies, including microelectronics, optics, MEMS technologies, advanced algorithms, and component architectures. Before that, he was the chief scientist and the deputy director for the office, and he oversaw probably one of the most impactful programs that DARPA has done, which is the Wide Bandgap Semiconductor Program, which has really led to a strategic advantage for the United States in a lot of RF technologies, phased array technologies, electronic warfare, and so forth. And before that, he was a program officer at the Office of Naval Research. From 1989 to 1997, he was a principal member of technical staff at Sandia National Laboratories. He has a bachelor's degree in physics from Gettysburg College and a master's degree and doctorate in electrical engineering from the University of Delaware. So he should get along very well with Steve McKnight, fellow alum. John was awarded the Exceptional Public Service Award from the Office of the Secretary of Defense for his service at DARPA. He's a fellow of the IEEE. He's the Institute for Electrical and Electronics Engineers. He's also an associate fellow of the American Institute for Aeronautics and Astronautics. He served on the Air Force Scientific Advisory Board from 2010 to 2014, for which he was awarded the Department of Air Force Commander's Public Service Award. Please join me in welcoming John Zolper.
Thanks, Sanjay.
John, thanks for coming.
All right. Thanks, Sanjay. He had to read the whole thing, so that was a long thing.
There's a lot of good stuff in here.
I do take the great credit for bringing Sanjay to DARPA, and I was looking at his bio. He came there in September 2007. I think I left in December, so I apologize for that. That's one thing how DARPA works. You only stay there for a short period of time, and you move on to do other things. The other important thing on my bio that he didn't read is I have a son who's a Hokie. So my oldest son graduated from Virginia Tech as a computer engineer, and he was going to be here because I said, come here and ask me hard questions. But the company he works for called the meeting at 4 o'clock. So he works for Raytheon, so I couldn't fix it. So anyway, so he may show up, but he may not. So glad to be here. We actually tried to do this last spring, and schedules got crossed, and I couldn't make it, so I'm glad I was able to come here today. So technology solutions for a safer world. So what does Raytheon do? It's actually our vision statement that I'll wrap up with. So what we do is develop technology, global technology, develop innovative solutions to make the world a safer place, right? So really developing defense solutions to make the U.S. stronger, defense stronger, our allied partners stronger, with the hope that you never actually have to use it, right, to make the world a safer place. So what I wanted to do today, just got to start out with a few slides on Raytheon. So if you don't know what Raytheon does and who we are, I'm going to spend a few slides talking about Raytheon. Then go into the National Defense Strategy. So the Secretary of Defense released his strategy at the beginning of the year that lays out his priorities, lays out the state of the world, and is very frank in the state of the world and the threats and challenges that we have. And then talk about how Raytheon looks at that as our primary customer and does technology planning to decide how we're going to invest and make decisions. So that sort of sets the framework. Then talk about innovation at Raytheon, and I'm just going to give you one example. So I lead a company-wide innovation challenge, and I'll give you one example of the way we can foster innovation across the company and tell you what I mean, at least when I say innovation, what I mean by that. And then briefly talk about 3 emerging mission needs. So at the top level, missile defense, electronic warfare, and cyber. Just try to give you a little bit color on those. Obviously, I'm not going to be able to talk about in much detail about any of those, but tell you a little bit about Raytheon does, how we think about those problems, and some of the things we do. And wrap up and save time for questions as we go here. So this is Raytheon, a technology and innovation leader specializing in defense, civil government, and cybersecurity solutions throughout the world. Last year, our sales were $25 billion and 64,000 employees. Headquarters outside of Waltham, Massachusetts. My group is at the corporate engineering and headquarters in Waltham, Massachusetts. I slid down the street in Roslyn, personal choice. When I joined the company about 11.5 years ago, decided I would stay here. So what do we do? So obviously we align with our customer priorities, right? And I'll sort of build this theme up to the National Defense Strategy, talk about it, but look at the key areas that Raytheon does business in. Missile defense, Obviously something that you hear about a lot in the news with North Korea. But we basically do the whole, in other areas you talk about the kill chain, sensing, tracking, engagement, solution analysis for missile defense. And I'll say a little bit more about that at the back end. Command and control, the picture there is showing what's called the Zumwalt destroyer. So that's the sort of next generation destroyer. If you go across the bridge in Bath and look at the Bath Ironworks, you'll see number 2 sitting there in the river. Number 1 launched about a year or 2 ago. We basically do the whole ship integration there, but all the weapon systems, the integration systems, control systems, command and control systems. Sensors and imaging, that's sort of a core part of our business across the company. Any kind of sensing and imaging, whether it's RF, electro-optical, IR, we put it in space, we put it on planes, we put it on UAVs. Actually, the pictures you've been seeing about Hurricane Florence, those awesome space pictures, that comes from a Raytheon imager. So our VTRC sensor that NOAA puts up, that takes those awesome pictures. And most of the weather data that you use comes from a Raytheon sensor, and we collect that data. Cyber, we do cyber in all domains. I'll say a little bit more about cyber towards the back end. Electronic warfare is how you engage in this RF environment, right? And pay measures and countermeasures with your adversary where he's trying to stop you from communicating or using your radar and other things, and how you impact what they do. Precision weapons. So Raytheon is the world's largest missile supplier, but it's all about putting the effect where you need it. So all the electronics and control systems and guidance that go into those missiles, really some of the most complicated systems you can think of. We do training and we do mission support. So obviously after we deliver systems or support the government and mission support, those are our main focus areas. We're a global company. So this slide says we do business, I think, in 80 companies. Last year, about 30% of our sales was international, about 40% of our backlog. So those are things we're going to sell in the future with international. We have, we've been in the Middle East for 50 years. I think we recognized being 50 years in Saudi Arabia this year, so we've been there for a long time. To do some of this international business, we often have landed companies. That means we actually establish a legal entity in that country, like in Australia, in the UK, in the Middle East. So help us both work with the local talent and meet our customer needs that way. So international is a big deal, and that's growing. And then these are our 5 business units. One of them is a commercial business unit. So on the right, ForcePoint is a commercial cyber business. So I'll talk more about cyber a little bit later. Basically, we've been involved in cyber for a long time, thinking about how we use cyber to defend our own systems and defend our own networks. A couple years ago, we decided we wanted to move into cyber commercial market. And to do that, we actually had to get access to the commercial infrastructure and commercial path to market. So we formed a joint venture called ForcePoint, and that is a commercial entity that sits off to the side of our other 4 main businesses. So Integrated Defense Systems is headquartered in Tewksbury, Massachusetts, outside of Boston. Think large radar systems. So when I said missile defense, they build the radar systems that sense those missiles. They build the naval radar systems. I'll talk a little bit more about that. Intelligence and Information Services, they're actually headquartered here locally out in Sterling near Dulles. As their name suggests, they work a lot with the intelligence community. They do a lot more software and cyber, and then also service businesses. Missile Systems is headquartered in Tucson, Arizona. They do everything to do with missiles. So every missile system you can think about, they have a play there. And where they're going is into hypersonics, directed energy, high power microwave, those type of things are the future directions. And the last one, Space and Airborne Systems, is headquarters outside of Dallas in Richardson, Texas. Again, as the name suggests, is sort of all sensor or electronic systems that go into air, UAVs, satellites. They build the guts that make all those things work. Okay, so that's Raytheon, big company, does lots of things. Sort of the way to think about Raytheon is we develop all the sensors and electronics and software that go inside the system. So we generally don't build the platforms, we don't build the aircraft, but we build all the electronics and sensors that go into it. So what I wanted to do next is sort of set up the back end of the discussion. We'll start out talk a little bit about the National Defense Strategy and how Raytheon thinks about our technology planning, because then that'll lead into a discussion about what does innovation mean and how do we do innovation, right? So the 2018 National Defense Strategy, right, released by the current Secretary Mattis in the beginning of this year, laid out his view of the world, and actually in a very frank way. Some of the prior defense strategies sort of were obtuse about who our adversaries were and how the world was changing. This document is very direct, right? We no longer talk about near-peer threats, we talk about peer threats, right? We have a peer threat in Asia, China, we have a peer threat in Russia, and it's no longer that we're head and shoulders above everybody. Now we're at the same level, and we have to up our game to get better. So what does he emphasize? He talks about delivering performance at the speed of relevance. So, there's a tendency to always want to make things a little bit better, to get a perfect solution. It doesn't do any good to have a perfect solution if you're late to the fight. So the Secretary has really emphasized you got to do things on a faster tempo. It's better to have an 80% solution out there the warfighter can use than trying to optimize it. Organize for innovation. That's both within the department and externally with their customers. So Defense Innovation Unit used to be called Defense Innovation Unit Experimental. Now it's a permanent entity, right, to work with commercial vendors, suppliers, and pull that into the department. The Strategic Capabilities Office is another sort of up-tempo office to try to work and improve capabilities. So lots of emphasis. And within the department, people talking about you have to be willing to take risks, right? You'll have to be willing to push the needle and make things happen. Obviously, you've got to drive your budget and affordability. Streamline rapid iterative approaches from development to fielding. Really, that means more prototyping. Again, you don't have to get the perfect solution. It's better to get something out there to understand how it works, understand what its challenges are, and work on it to make it better. And then harness and protect the National Security Innovation Base. The key point there is the National Security Innovation Base. So you used to talk about Defense Industrial Base, which generally meant the big integrators, right? Raytheon, Northrop Grumman, Boeing, right? That was a defense industrial base, and all the suppliers that went with them, right? But now they specifically no longer use that term. They talk about the National Security Innovation Base. And the point is, innovation and solutions can come from anywhere, right? Come from commercial, can come from companies like Raytheon, come from small companies, but they're making a very concerted effort because they understand our adversaries are pulling from the same base, right? We have to be able to pull from that complete base and do it in a more robust way. So that's a very important thing, but it also says harness and protect, right? They understand they also have to nurture this innovation base, right? It doesn't exist by itself. So there's a back and forth there. So those are the top level priorities. And then the document talks about modernization capabilities. So these are the areas Secretary Mattis says we have to do more and we have to get better. So when Raytheon looks at these and sort of set it up by the earlier discussion, these are areas we've been working on, right? These are in our sweet spot. These are what we do, right? So nuclear forces, let's talk about recapitalizing the nuclear forces. So we do the sensor systems. We don't do the delivery systems except for the missile systems. But whether it's sensors, electronics, control systems, those need to be upgraded. Space and cyberspace as a warfighting domain. So a couple key points, right? The space used to be, we were dominant in space, and we could sort of do what we wanted to, and weren't other major players there. But now our peers are there with us, so we can't assume that we can do things there that we could do before. And cyber is sort of similar, right? That's a whole new domain, and we're just sort of learning what it means to think about it in a warfighter perspective. So lots of technical and operational challenges to go with that. Command control, communications, computers, intelligence, and surveillance, C4ISR, is sort of your eyes and ears, how you understand the battle space and communicate across the battle space. That's critical as you want to do more distributed operations and think about swarms and other type of solutions. Missile defense, I mentioned, and I'll say a little bit more about that. Joint lethality and contested environment. So joint means that we have to work better within ourselves, right, across the services. It's not good enough to have the world's best Air Force if they can't work with the Navy and the Marines and the Army, right? So thinking really joint, but the point is, what does that mean from a technical solution, capability perspective? What are the things you have to do? And you have to operate again in this environment that's contested, so where our adversaries are taking away our spectrum or denying us access. Forward maneuver and posturing, advanced autonomous systems. So that's a key theme through the document. And actually it calls out artificial intelligence and machine learning as a particular area that we have to invest in, that we will invest in, that will deliver some of these capabilities in the future. So that's really captured here in the autonomous systems, but that topic cuts across really all these domains. I'll try to give a little color on that as I talk about some of the other areas, particularly electronic warfare. What does machine learning mean in the context of electronic warfare or real-time systems, right? So autonomous systems, and then resilient and agile logistics, right? You got to have the framework that goes with it. So those are what the government, Department of Defense says we have to do. Those align very well with what Raytheon does, and we're moving out. The other point is, a lot of times there's strategic documents, strategic guides that comes out, but you don't see the action following it. In this case, the budget that has come out from the government has lined up right behind these documents and say, these are the areas they're going to invest in and move out in. So it's really impacting across the community. Okay, so there's this great strategic document. All these areas they're talking about, they're looking at. So how does Raytheon start thinking about it? So I told you we're this big company, 64,000 people, $25 billion, right? So how do we start thinking about how we're going to invest and what we're going to do, right? So first what we do, we sort of think on the left-hand side of this graphic, right? We think from a mission and threat perspective. So that's really going to that document and then getting the classified version that's behind that and talk to your customers. What are the real issues out there? What are the real problems they're trying to solve? Just we do the same in the commercial space. You do it in a different sort of terminology way, but understand what your real customers' needs. We call those missions and threats. And then we sort of, from a system engineering perspective, say what kind of solutions and architectures can help bring capability to our customer against these threats. To particular systems, right? If we had a new radar, they could see farther. If we had electronic warfare system, they could jam from farther back or be able to analyze waveforms faster, right? That would be a new capability. That would be the system. Right? And then at the same time, we're looking at our technologists. So this goes from the science to the technology to the system. So those are where your solutions come from, understanding the art of the possible. Right? Where is science going? What's the new breakthroughs? Where are things going? What's the new technology? What's the new electronics? What's the new sensor? What's the new algorithm, right? So you sort of come at it from both sides and understand the art of the possible. So the top gives you needs, and we flow that over to a business analysis. So flow that into our roadmaps, what's needed, when is it needed, and that can then prioritize what areas we should invest in, right? At the same time, I lead a company-wide competitive assessment. So we have what we call technology focus areas. So those are at the top level, about 75, but in each of those might have 5 or 10 what we call enabling technologies under those. And on a regular basis, at a company level, we're looking at those and say, how are we doing? Are we ahead or behind of our peers? Is there a gap there? Is there something that maybe Northrop Grumman got a big award and we didn't? What does that mean? Or do we have a technology gap? So we're constantly doing that assessment, and it ends up being about over 400, 500 technologies. Sort of red, green, yellow. Are we ahead, behind, or different? And then we map that to our system solution space, right? So I might have a gap, but if it doesn't apply to a system I'm working on, then from a business perspective, it's not as important. But if I have a gap and I'm trying to meet a particular capability, then that's where I'm going to put my investment, right? So it's an ongoing process. It takes subject matter experts, so we pull in the experts from across the company in different areas, pull in our business leaders, and have an ongoing process that we lead throughout the year to make those decisions. At the end of the day, it's good judgment by experts, right, who are well informed. So that's sort of developing the integrated technology roadmap, really with myself and the Chief Technology Officer working with the business leads to do that on a regular basis throughout the year. So that frames what we're going to go and work on. So Sanjay asked me to talk about innovation at Raytheon, right? So I'm going to do that. So when I joined Raytheon about 11 years ago, they said they want me to be in charge of innovation. So my first reaction was like, what the heck does that mean? I was at DARPA, and knew what technology was, and I kind of knew what research was. But innovation is probably the most overused word in the dictionary or in our lingo today, right? If you have a problem, innovation. Have another problem, innovation. So what does that mean, right? So that was kind of my first question. Well, what do you want me to actually do? So let me just start by telling you what I mean when I say innovation, right? So you can go up and look at different definitions, right? So the act of introducing something new, a new idea, method, or device, a change that creates a new dimension of performance, deliver new value. But to me, there's two key pieces for innovation, and I'll tell you what my definition is. So this is the definition I use, and I use it in this innovation challenge that I'm telling you about. Innovation is a novel product, method, or service, so that's your something new, right? But provides a result with valued quantifiable gain, right? So it has to be something my customer wants, and he wants it by willing to spend money, right? So it adds business value. So I differentiate between research, right, which is the discovery of new ideas and insights, and that's really important. We do research to explore science and to start understanding our universe. And we may apply that to develop a novel product, method, or service, so that's something new, but it's in the context of a customer need, and that gives us our quantifiable gain. So new and business value. So understanding that business value is often where the technologists are challenged, right? And the people who understand the business value are challenged by what the technology can do. So the challenge is bringing those two together. So my boss, Mark Russell, who's the Vice President of Engineering, Technology, and Mission Assurance, basically think of those as the functional matrices that cut across the 64,000 people. So he kind of owns most of those people in a matrix organization. He says, our engineering culture drives Raytheon innovation. We develop unique capabilities that meet our customer missions needs. So I would assert engineers by definition are innovative, right? We look at problems, want to solve problems, and that meets someone's need, right? So that's really Raytheon's culture. I like to point out that our CEO is a PhD in electrical engineering and control systems from UCLA. So you got to know your stuff when you go talk to Dr. Kennedy. And I think that's really cool. So one quote I like to use, I say don't quote other people because that means you don't know what to talk about yourself, but I like to use this quote. So Theodore von Braun, who's the father of supersonic flight, right, says, scientists discover the world that exists, engineers create the world that never was. I think that's pretty powerful, right? So research is discovery, what's out there. Engineering is developing solutions. So Raytheon is an engineering company. It's very much a culture of engineering and doing that excellence. So we talk about excellence and domain knowledge, right? So again, you go talk to the boss. If you don't know your stuff technically, it's going to be a really bad meeting, right? So I think that's really cool. That was our culture at DARPA, right? If you didn't know your stuff, it's going to be a short meeting and you're not going to get your program approved. Okay, so now I want to tell you about, so I lead this Raytheon Innovation Challenge. So there's lots of ways to do innovation. This is just one particular activity that I lead. It is not how Raytheon does innovation. It's just one activity that we do that fosters innovation. We do all kinds of things sort of locally, globally, within different businesses to really foster that culture of innovation, which is really what engineering is about, to foster it. But let me tell you a little about this because I think it gives you a little bit of a flavor of how you can be successful in innovation and, again, something new and business value. So you have to tie together customer needs, the market viability, and technical feasibility. That's my little Venn diagram there on the right. And so what this is, I call it a targeted innovation program, soliciting ideas from across Raytheon to key customer capability needs. So when I joined Raytheon, they said, John, we want you to lead this innovation activity. Last year, we had an innovation workshop. So we picked a couple key themes of things we wanted to work on. And we said, well, we know we need to invite a diverse crowd to this because you get better ideas if you invite a diverse crowd to a workshop. And we know who the smart people are, so we're going to invite all those smart people, right? Smart people, diverse crowd, come together, tell them what the problem is, they'll solve it, and then after that week, we'll be good to go, right? So that happened before I showed up. I showed up with the output of that, which was some projects they'd come up with, and those people at the workshop dutifully hand them off to someone else, said, we came up with the project, you now run this project and make it successful. And we won't talk about the details of the projects other than to say, if those people weren't domain experts in the area they were working, they might come up with a really cool idea, but 10 other people had showed why it didn't work, and we had to go try it again and show why it didn't work again. Doesn't mean you don't look at it, but it just says you have to also understand the domain. So the first thing that I said, DARPA, what I know is the idea comes with a person, right? So we can't have someone else develop the idea and someone else run it. So I said, I want to find the people and let them actually run the projects. So we basically developed the process where we could sort of put a broad out area announcement across the whole company, ask for brief white papers, and people can put in their ideas. And those people, we evaluate those white papers, as you might do in any kind of solicitation. And the ones that seem most interesting, we invite them to a workshop, and I'll tell you a bit more about that. So how does it work? Targeted capability statement. So I work with the businesses, look at what the government is asking for and pick some key areas. It could be either a capability gap where we need some new ideas for GPS denied navigation would be an example, or we need some things for non-lethal defense. Or it might be an application of new technologies. You might say, well, machine learning is a big area. Do people have any ideas on how we could use machine learning for our products? So tell me about that. So we sort of do both of those. It goes out across the company. Anybody can give us a white paper. We just ask for 3 pages. We have a panel that looks at them and recommends the strongest ones. So those people come to our workshop, and I'll tell you a bit more about that. And then actually the people at the workshop help identify the most promising ideas to go forward that get funding to nurture further, and then my goal is to transition on to the businesses or to a customer funding. So independent of those projects that I'll tell you a bit about, I get broad exposure across the company of some key customer care abouts that people might not have heard about. So I'm in my day job, head down, working on this. I didn't know about these other things the customer wanted, and actually what I was working on over here might actually solve that problem over here, but I didn't know about it. So that helps. People get pumped up by having a chance to turn in their idea, get feedback on it, and potentially come to this workshop. And we start to develop some novel ideas and intellectual property. And it just goes with enhancing enterprise collaboration. So people come to this workshop from all parts of the company, and they learn a lot, and they strengthen that culture of innovation. So tying together those customer needs, and which is sort of the solicitation announcement, market viability type of things. Innovative solutions comes with the people, but the key thing is that passionate project leader comes with that idea, and they're going to make it work. So at this workshop, basically, so typically I might get 200, 300 papers. We typically invite 10 plus or minus to each of the challenges. And then they spend a week working within their challenge to look at their ideas. So first we start out with say, get together with your peers and describe your idea. Tell me more about it. So first we're talking about understanding your idea, and the idea of that outward arrow is to expand the idea. First we want to be making it better, right? What can you do to make your idea even better? Either other applications, growing the solution space, and do it in a collaborative environment. You're going to get feedback from your peers, and we have processes we've developed to help that work, right? So we're expanding the idea through different mechanisms. And then about halfway through the idea, we ask the teams to start to prioritize our idea. And the way we do that, sort of thinking about angel investing. So we have the people in the room say, you have so much money. You can only invest so much of it in your own idea, right? Because, of course, my idea is the best. I'm just giving all the money to myself. Well, so we've got to break that model. We've got to say you've got to actually invest in some other people's ideas, and there's always a balance trying to figure that out. But we tell them what an algorithm is. You've got to invest so much in the other people, right? And then pick out the ones that they think, the group now, in that angel sort of investing mindset identifies the strongest ideas. And then they spend another day trying to even make them better. So, why didn't they invest in my idea? Maybe I didn't explain it well, or maybe I didn't answer a point, so I have another chance to go through it. So the ideas get strengthened. We have another round of sort of this angel investing. And at the end of the week, sort of the top ideas bubble to the top. So it's the idea and the people with it, right? So they come out at the end of that. They outbrief, and then I give them what we call seedling money. You just been through this intense week. So I've had this week described as Raytheon Shark Tank. And so people get really exhausted because I say, only work from 8 to 5, and at 10 o'clock they're all still working on their idea, right? John, your week was too long. Well, you could have left, But everybody gets really, engaged and really excited, right? And they go back and tell their peers, hey, this was the best thing. Not only did I work on this thing, but I met all these other people from Raytheon. It was really exciting. So after that, we have a series of gates where we actually fund them. We help mentor and nurture those projects and help them be successful and go through the gates with that. So after the workshop, I always do a survey. So this is just one of my questions and a couple of the responses. So most liked and overall. So at the bottom, you see the crowd. We end up having about 100, 120 people for a week. The one I liked, this is, I must admit, I wasn't jumping up and down about going to my first RIC, but this was truly a great experience, and I would not hesitate to go again. So, of course, I had to pick that one out. So then you get a little Texas draw. I'm telling you, I thought the 2013 workshop was pretty good, but this one was even better. So people get really excited and about the ideas, collaboration, and networking. Pretty powerful. So just an example. So these topics, so typically I do 4, 5, 6 topics, right? And behind each of these titles, there's a description just like you would have in a broad agency announcement from the government or something. It doesn't say, I want a pencil. It says, I'm interested in carbon materials, right? And tell me what you can do with carbon materials. So you have to tell me what the technical idea is, but also the business use case, right? But I'm only asked for 3 pages, so I tell my reviewers, don't expect, a full polished proposal, right? Because these people did them on their lunch break and on the weekend, right? So part of our job is to find those nuggets in those proposals, right? And then we nurture them on from that. So I won't read all the topics. So, but you can see the flavor. There's some around, like the first one, the 5G. The challenge there was 5G is exploding, next generation wireless wireless technology. We're not going to go into that business. We're a defense company, but we can use technology that's being developed in the 5G community to our systems. So look at that commercial technology. Tell me how we can use it in our system. So that's an example. Factory of the future is about Internet of Things, industrial Internet of Things, right? How you can apply that to your factory. So tell me a particular problem we can solve by doing more sensing and data analytics and make our factories better. So that's the flavor. And we take sort of a dozen projects throughout the year and then work to transition them onto the businesses. So that's just an example. I think so I've been doing that for about 10 years. It's going really well. But so again, that's not how Raytheon does innovation. That's how Raytheon does the Raytheon Innovation Challenge. But we do innovation lots of different ways, right, across the company, locally, globally, at the business unit, at the product level. But I wanted to give you that example about how a big company can still, I describe it as entrepreneurship, right? You don't have to leave the company to get your idea funded. You can actually do it this way, right? So you can get excited, and I'm going to help you, and I have a staff that's going to help you and mentor you, and we all get vested on your project being successful. So that's a good thing. All right, I want to mention 3 key mission areas. I tend to talk fast, so hopefully I have lots of questions at the end. Missile defense, electronic warfare, and cyber. And obviously I'm not going to be able to go into any of these in any detail, but I wanted to sort of give you some flavor about sort of how Raytheon, some of the things we do in these space and what some of the challenges are and opportunities. And obviously these are all things that you'll find prominent in the National Defense Strategy. So what is this? This is a picture, so what we call an operational view. We call the OV1. This is an operational view of air and missile defense radar. So AMDR, it's the Navy's next generation radar system for their destroyers, also known as a SPY-6. And I hope I got that right. We got the NRL over here so they can correct me if I got it wrong. But this radar has to do lots of things. So you see all kinds of beams coming up with all kinds of labels on there, all going in different directions, all doing different things. And it's the legend at the bottom left is saying there's also another radar system it has to collaborate with and work together to execute the mission. So the first thing you see, well, all these beams go in lots of different ways. So one of the things you need to do there is called digital beam forming. So the electronics behind this antenna that shape these beams and point them very fast in lots of different directions. So you're emitting RF energy over here, you're illuminating a target, you're getting the return, you're analyzing that target. At the same time, you're looking over here, looking over here, looking over here. One of the reasons I like to talk about this particular system is when I was at DARPA, so Sanjay mentioned this wide bandgap semiconductor technology program. Actually, when we were talking about selling that program, the Navy said, I have a problem. They said, I have this radar on my destroyers, but I would like to see farther and see smaller targets. Actually, what they really wanted to do was be able to stand back farther and see the same target in the same spot, right? So they wanted to get their ships farther away from where their threat was. And guess what? Their ships can only be so big, so they can only put so big of an antenna on their ship, and they only have so much power that they lug around with them. So even though they have a big power plant, right, they can only put so much of it through their radar antenna. So in 2000, I was still at the Office of Naval Research, and the Navy led it's called the Navy Radar Roadmap study led by MIT Lincoln Labs, and said, okay, got this mission, we want so much more improvement in our radar. Talk about the power aperture gain. They want 15 dB improvement in the power aperture gain to do this mission. What are the options to do that, right? New architectures, new construction. Maybe I can make the aperture a little bit bigger. Basically, went through the trade space and said, well, we really need to have more power in each element of your radar. So the way this radar works, you have lots of elements, active array, electronic steered array, has lots of elements. At each element, you have a solid state amplifier. And basically what they needed to do was be able to take the power of that amplifier and increase it to be able to get this power aperture gain. Just turns out at the time there was a new semiconductor material that was making progress called gallium nitride. I was investing in that at the Office of Naval Research and Electronics. There was a whole commercial community investing in it for light-emitting diodes. So your TV today, the reason it's this thick, instead of used to have that, cathode ray tube that was this big and weighed a ton. The reason it's this thick is because it has gallium nitride light-emitting diodes that the illuminator didn't have a solid-state light device that could give you the right wavelength of light, basically. So now those blue LEDs that started just by being able to, the missing color in LEDs was blue. This particular semiconductor has a band gap that gives you the right wavelength of photons that can make blue LEDs. So now I know how to make solid-state displays. Now I know how to make solid-state lasers a shorter wavelength. You can make your Blu-ray that way. And now I know how to make white LEDs. You put a little coating on top of it, you make it white. And now you can go and buy your LED light. That's a gallium nitride LED. So that technology was exploding. People who make transistors said, I know how to take that same material and make a transistor that's sort of 10 times better than what we have, actually probably 20 times better. And the Navy said, well, if I had that, I could do my mission here, right? So it just happened, the technology was coming along just enough, but it was still too immature. Navy said, if I had it, I can do this mission. And we were able to convince DARPA to put a pretty good amount of money, about $250 million. Ended up being over 13 years. We sold it as a 5-year program, but it kind of got stretched out a little bit. But at the end, every new RF system for the military, except for vacuum tube systems, it's another discussion. But every active array system, radar, electronic warfare, communications now has gallium nitride as a solution. So it meets that mission capability. But then missile defense, that's just the radar that does the sensing. So now I can stand back. I can see this missile coming up. Then I have to analyze it. I have to engage it. And what's amazing is we do something called kinetic kill. It's basically a bullet hits a bullet. There's no explosive on your interceptor. You actually steer that interceptor and just slam into the missile that's coming in. And if you want to talk about hard engineering problems, that's one of them. And that's the type of thing we do. So what's the next generation? We need to do more of that. We need to do it better. We need to do it farther away. So that whole sort of process of missile defense is an ongoing challenge and a key investment. So these radars are a piece of it, but all those other pieces are critical as well. So the other area I want to talk a little bit about is electronic warfare. And again, I'm not going to be able to say too much, but I wanted to sort of tell a story or paint some pictures about what electronic warfare used to be, what it is now, and where it's going, and some of the things we need to think about. So electronic warfare is the idea that I have a plane, I'm flying into an adversary's area, right, and I have my radar that's searching around, looking at what's there and going to do. Well, they probably might not want to be flying in there, right, so they're going to set up a jammer. There's a high power source, and they're going to irradiate my radar and my communications, just put so much power on it that my system can't work. So that's the simplest version of electronic warfare. So typically what we do is we look out there and say, well, I know that particular radar. I've seen it before, right? So I can look at my library and say, because it's this frequency and this type of waveform, I know what it is. And I have some ideas on how to get around that radar. So I'll do that, and then I'll continue on. But what's happened, right, as we all know, electronics has proliferated throughout the world. So where it used to be the defense industry had the best electronics, so now everybody has the best electronics to a degree. So the proliferation of these type of RF systems has exploded. So it's no longer enough just to say, well, I know what radars are out there. Things are dynamic, they're agile, they're changing, they're doing frequency hopping, they're doing software-generated radar and radios. So we now have to be able to, in real time, sort of figure out what's going on. So the picture on the right is trying to show sort of our algorithm, trying to make a decision about what technique I should use. So it's looking and making a series of decisions, and the growing blue is saying that's the one that looks like the most probability of success. So I'm going to sort of go along that path, right, and then see how it works. So what are some of the opportunities here? So this is where I want to talk a little bit about machine learning. So artificial intelligence and machine learning. So one of the, actually, let me talk about that on the next slide. I think I said it one more time. So complex crowded spectrum. So I sort of talked about this, but in the red box here, frequency waveform, agile threats amidst a rapidly changing background severely challenges identification and association, right? So again, I used to know if I was going in a certain area, I'd know what to look for, and I'd look at my library and figure it out. So now my architecture, I can make it wider. I got to look at everything. I got to be able to what's called nulling, right? So if that jammer is over here, I'm going to make sure I don't shine any of my energy over there, right? Or I shine extra energy there to interfere with him. And then I got to think about new features to identify those different threats. So then algorithms, advanced algorithms. So this is where I was going to talk a little bit about machine learning. So machine learning is sort of, well, I said innovation is probably the most overused word in the technical community now today. Machine learning and artificial intelligence, I think, is competing with that. It's now the answer to everything. So artificial intelligence, actually, I like to just use the term machine learning, which is more technically accurate technically. So machine learning is the idea that if I have a database, I can do what's called statistical learning, right? So before that, we did what's called expert systems, which says, I know the rules. I know, if I do A, B, and C, and then this, then I can execute my problem. It's an expert system, and I have to learn those expert systems. But machine learning says, I don't know what the rules are, but I have this big data. I'm actually going to basically learn the rules, learn the model from that data. Statistically, so if you have that big data, you can churn on it. You can learn what basically that's where your neural network comes in, your deep learning neural network. So you learn what the weights and connections are, you come up with your model, and then for that particular problem in that data set, it can be very accurate and precise. So what people don't often talk about is that learning step or training step can take days or months or years. So when Microsoft won in AlphaGo, they had trained up their deep neural network for, I think, 3 years. And then they were able to play that game and win that game. So that's great if that's the type of problem you're trying to solve. The first statement is everything you're looking for has to be within that data you trained on. If it's something outside of that data, all bets are off within context, and we can discuss that more. So that's the first statement. Second statement is if you have time to do the training, that's fine. You do this training step, you generate your model, and then you do what's called inferencing. That's really the matching function. I now have this model. I'm going to look for whatever I'm looking for, picture of a cat, and I'm inference it. I can do that very fast, very low power, very accurately, so long as that what I was looking for was in this data set over here. So that's great. The point I'm making in this electronic warfare, we're doing things without that big database that's robust, that has all the answers, all the threats that we're looking for, because the environment is always changing. So the research challenge is how do we apply some of those techniques to what we call a sparse data set. So my data set didn't have everything in it that I wanted to look at, and a dynamic data set is changing over real time. So one of the big research challenges, how do we take some of the techniques in the commercial machine learning space, apply it to this type of problem, and then I have to do it in real time, right? So I have to do this learning or training in real time. And part of the answer is it's going to be a combination of techniques, right? It's not just this technique, machine learning, it's other techniques. But that's where a rich research agenda exists to look at those type of techniques. So new approaches develop a spectrum-based line for areas of interest, look for new signals. But then the last one, bandwidth and processing needs will drive new hardware solutions. So that last point basically says, you know that PowerPC processor that you have in your laptop, that's actually not really good about doing this inferencing problem with a high efficiency. And it's also not really good at doing this training process. That's where NVIDIA learned that this vector processor they developed for graphics engines and game machines is actually pretty good at doing this training process. So they're optimizing their GPU, graphic processor unit, for machine learning training. And then there's another set of problems. How do I actually do the inferencing at low power? So the community from a hardware perspective is actually branching out to look at complete new architectures for their hardware processors to address these machine learning problems, of which there's many, and I can take questions and talk more about it. So the last technical area I just wanted to touch on, so cyber hardening and resiliency for weapon systems. So Raytheon has been working on cyber for a long time. We first think about cyber in the context of our weapon systems. So what does that mean? So any system that has software in it and processing and can be reprogrammed, you have a cyber vulnerability, right? Because if someone else could get in there and change something or do something, it wouldn't behave the way you had intended it to. And in our business, our things have to do exactly what they're intended to do, right? Nothing more, nothing less. So we started probably at least 10 years ago. We established what we call our code center. We had a bunch of Virginia Tech folks out there to visit, called our Cyber Operations Development and Evaluation Center. It's out in Sterling, out near Dulles. And it's actually a center to be able to bring weapon systems or part of weapon systems in and test them, right, for cyber vulnerabilities and effects. So sometimes you have to do an RF chamber, sometimes you have to do it in other ways. So we're not primarily focused on what would be called enterprise cyber, although actually that commercial business that I told you about does that, and we do it within our own systems. But our sort of key differentiator is saying for all our systems, we need to think about cyber security and cyber defense up front, right, and sort of change your mindset and ensure that these systems are hardened, right, against these type of threats. And hardened, the term of art really is resiliency, so you're never going to make things perfectly hard, right, but you want to make sure they're resilient, which means if some of them, part of them is compromised or changed, it still executes the system or the solution that you need it to do. So I can't really say a lot more about it other than that whole mindset of what it means to have cyber resiliency and cyber hardening, and look at it from throughout the product development and some discussion I had earlier today. What does it mean to have a cyber engineer, right, a cyber expert? To me, it first means you're an expert in the fundamentals, which means computer science, computer engineering, sort of data architectures, and security. So security really means risk management, right? So how do I decide how much protection I need? And then you apply that to a certain domain. So then you become an expert in radars, or you become an expert in enterprise internet, or an expert in communications. And those two things, is what would make a cybersecurity expert. Raytheon sort of at the higher levels, right? It's the core cyber understanding and the mission hardware understanding. So with that, I'll wrap up. So this is our what we call our vision statement, right? So one global team created trusted innovative solutions to make the world a safer place. To me, that's a powerful statement, right? So we're global. We develop solutions that our customers trust. They're in fact innovative, so they're new and they have customer value. But our goal is to make the world a safer place, right? To deliver capability to our country and our allies, right? To make the world a safer place. And so that's what gets me excited about coming to work at Raytheon. So with that, Sanjay, I think I saved some time for questions or whatever we do.
Thank you, John. That was excellent. So a couple of housekeeping items. If you would like to ask a question, there's the microphone. There's a little vertical gray bar please press that. Your microphone should turn red, and you can ask a question. That way, it'll get propagated.
I'm told this is streamed live. I don't
It is
streamed, network.
It is a live stream, so there may be people in cyberspace who would like to hear your question.
That's pretty scary.
Second housekeeping item is after we'll do about 5-10 minutes of question and answer, and we will adjourn back to the reception. And hopefully, John will stick around for a few minutes, and you guys can engage further with him with any other questions that you may have had, or just conversation and wine and food. So with that, I'll open it up. I saw Ann's hand.
Thank you so much. It was really interesting. Could you say a little bit more about the process you use for selecting the innovations? You talked about a review process and kind of drilling down. Is it pretty much a collective effort, or are there really explicit criteria that you use for deciding which ideas bubble to the top? Is it a combination of those things?
Yeah, it's sort of a combination. So at the first step, we get these white papers, and we sort of put a team of evaluators together, and there's sort of criteria, right? Is it new? Originality? Is it technically feasible? You're not breaking any known laws of physics, at least in the 3 pages that you gave me. We can see that it fits within Raytheon's sort of business. It's not a commercial product, right? So there's a business scope, and originality, technical feasibility, market potential, and I'm forgetting one. So we have 4 criteria. So that sort of gets them invited to the workshop. And this workshop really has evolved over 10 years. Every year, I showed you the survey I do. I do a detailed survey and tell us what worked and what didn't work, and we try to get it better. A lot of that, so we sort of, the way I tell the people is we apply those same criteria, but the group has to apply them. So we have sort of a series of processes that they can work with their peers and get feedback from their peers, and they have to present it to their peers and get feedback, and their peers tell them what they heard, what they didn't hear. So a whole series of processes the whole week, so there's not sort of one gate. So that goes through the week, and then there are a couple of anonymous voting opportunities, right? So it's not, I try to remove the peer pressure, but people can vote, and I tell them, you're here this week to pick the best ideas for Raytheon Company, right? It's not about John Zolper's idea, right? And that's the hard part, because everybody came there with their ideas, and that's always hard. But we try to keep reinforcing that. The goal here is to get the best value for the company and try to keep coming back to that. And we have people mentoring them, and we have facilitators, and we have people who can help educate them or help them with their proposal. So there's a whole series of activities, but sort of it's that criteria, but then we asked actually the groups to help identify which ones they think are, so that peer evaluation is very powerful.
And do you think that has had a cultural impact on Raytheon? Can you see changes in the way Raytheon operates through this workshop?
So, I mean, that's maybe a little bit strong, because there's only 50 or 100 people coming to this workshop with 64,000 people. But what I do know is they go back to their businesses and tell their peers and colleagues about what happened, and they now have a network of people they wouldn't have ever met before, so their visibility in the company has grown. So I think it has, and I can't say, and again, the point is that's not, if I just did this and did nothing else, right, it wouldn't have as much impact. But these people are getting pulled off their day job. Everybody has a day job, right? It's not like I'm sitting around waiting for John Zolper's Innovation Challenge. I'm going to work on that. They still have a day job, and they have to go work on that. So their manager has to buy in and send them to this. I don't pay for them to come, actually. The businesses pays for it. That's the first test. Is this important? You pay for it. If I pay for it, everyone wants to come, right? So, but if they pay for it, and so now I work through the businesses and the vice presidents to make sure it's supported. So there's a whole series of, those are all cultural things, right? That their managers see them come back and they're pumped up, right? And this is pretty good. Maybe I should send somebody else. So it's a series of things. I would assert, yes, it's made a change. It doesn't by itself change the whole company, but it's an important cultural aspect. Yeah.
Patrick.
Great. You talked about missile defense. The missile defense review is still ongoing. One of the major strategy documents of the Trump administration is still out there. I think there's more uncertainty regarding what would happen to this and greater bounds than some of the other strategy documents. What would you recommend for the missile defense review?
Wow, a powder puff question. So I haven't been involved in sort of even at our company level giving inputs to missile defense strategy. So I'm not going to be able to give you any particular recommendations. Yeah, sorry. Do you have some particular in mind?
Sure. Let me take a different direction.
Yeah.
I've heard so much about your great technology. Yeah. Could you say something about how you would integrate social science into Raytheon's innovation process.
Right, okay, no, that's a good one. So actually, we kind of have already, actually I didn't talk about it, so when we come to this workshop, we do a survey of the people before they come. We call it Innovation Style Preference Indicator. A company called Idea Connections came up with this idea. It's sort of like your personality profile, but in the context of how you think about ideas, right, and how you work in groups. So we do this to everybody, and as a good engineer, I was really skeptical of it. You know, come on, this isn't going to tell you anything about me that I don't already know. But what I learned is everybody's not like me, right? Some people like to work in groups. Some people like to work by themselves. Some people like to get into the details right away, and some people like the big picture. So we call those, so we have this whole profile, and actually some of these exercises we have during the week are optimized to get those things together. So it turns out you can also have a profile that says yes, no. I want to be in charge, yes, and no, I don't want anybody else to be in charge. You've probably been in meetings with these people, right? If you put two of those people in the same meeting, you're going to have a really bad meeting, right? Because they both want to be in charge. So that comes out in your profile. So, well, hey, guess what? I want to put one guy over here and one guy over here, right? So that doesn't happen. And I know the people who like the big picture, so part of the exercises, I'll put them all together so they can apply that technique. And it doesn't mean one is right or wrong. It just means you're looking at the problem in different ways. So actually, that's been one of the things that made this week really successful, is we actually apply that. And so we apply it at this innovation challenge. We apply it at some other workshops across the company. So it's a way to optimize your team dynamics to have better success on the outcome, depending on what you want to do.
John, great talk. Thanks for that perspective. One of the things you said early on is something I've been thinking a lot about in terms of the building's perspective on innovation, and this feeling that seems to be we need to get innovation outside of the normal industrial base, and that there's magic solutions out there only if we would listen to other folks. And that's had real consequences. Even when DIUX started, it was just kind of a fad, and you got Pete Newell out there talking about things. But now it's leading to real consequences. If you look at the Army's Futures Command with 4-star command equivalent to FORCECOM and AMC, how does a traditional company like Raytheon, who's been really at the forefront of innovation, look at that and really try to convince the building that there's still innovation? You got IRAD changes and all that. So how are you guys looking at that and trying to maybe either participate or counter some of that prevailing thought that there's better ideas out there than what our traditional providers have been able to get?
So, I share a lot of those perspectives that you brought up, and so what we do and what we have to do is we have to engage, right? So when these previous administration, it seemed like all the solutions were in Silicon Valley. Like, oh, that's great if you need software, but maybe if you want hypersonics, you might not find it over there. But we often, we also work with those companies, right? Small companies. So you have to engage across that full portfolio, right? And just continue to work with the customer to understand what they really want. I think a lot of times they don't understand what they really want, right? So the education process, and machine learning is a great example, right? That it's going to solve everybody's problems. Well, can we actually sit down and talk a little bit about, how it works and how it doesn't work, and what it can do, and what it can't do? So it has to just be a sort of a full engagement, and we have to change how we do business too, right? So the way I always say it is, geez, you defense contractors, you're really slow and you don't do anything fast and whatnot. So that's interesting, so I was in the government, so my observation was we're a lot like our customer, right? So our customer tends to be that way, and we tend to mirror our customer. So part of the strategy is saying that government actually has to organize for innovation. It's not just looking outside, right? They have to do some fundamental changes inside as well. But we need to work with them, right? It needs to be back and forth, ongoing. It's a journey, right? So it's an education, it's a discussion, it's what do you really want, right? What do you really need? What's the real solution? And there's lots of other things out there, and we need to pull them in and work with them and understand what it is. So we can't just say, hey, I got it. You just got to just come back to me. We got to engage the whole infrastructure, but work with our customer even more, right?
Yeah,
to have that discussion.
I think that engagement's important. One of the things in universities we're seeing is the devaluing of basic reason. Maybe devalue is not the right word, but the lack of understanding that the ability to pull on things, whether it's machine learning, comes from a whole lot of work over decades.
Right.
In a translational way that we have. And I'm not sure academia has really figured that out. That's something I've been talking with Teresa, and we're trying, the Air Force is doing their thing, really trying to follow this Army Futures Command a little bit.
Right.
But yeah, maybe the engagement is part of
So
the
I think that's a story we can't try to tell enough, right? And I try to always make that point, the difference between research and innovation, right? I mean, that innovation is mining the research, right? And as a country, we've sort of gotten our fundamental research and have clear applications. But as we go to faster and faster cycles and say, well, I know software can do it fast, so why can't you do it in the hardware and all these other areas? Well, because it's kind of different than that.
hypersonics is the perfect idea.
Right. Right. So I think we just as a community need to keep kind of explain that we've actually gotten away from investing in research, and then you're wondering why we don't have what's the next big idea? Well, you need to invest in that research. So I think that's really an important message across the board. It shouldn't be blue sky research, right? So I'm sort of a DARPA guy. You can have focused research. You can understand what you're trying to accomplish, know if you're making progress. But we're not really doing that sort of.
Maybe some of the academia and industry working together.
Yeah.
Okay. Let's take one quick one, Ken.
So I was very interested in the innovation challenge and this question of the passionate project manager. In your experience, do you get to a point where that project manager has to be asked to step aside or needs to realize that for the betterment of the project they need to step aside?
Yeah, so that would be a model of any startup company, right? The guy who starts the company in his garage often is not the guy who, except for Bill Gates, right, who ends up as the CEO of a big company. So typically, at least in my innovation process, it's sort of that very, very early stage, right? And I've had cases where the person just didn't want to let go of it, right? And it's still my project, so absolutely, right? So we have to try to manage that. So I do a lot of mentoring. I have people on my staff that I also assign them to the project to sort of monitor and mentor. So help to try to bring other people on their team to help them with that. But you have the same problem. Even just going into the challenge, right? They got invited to the challenge because they had an idea. Guess what? They all want their idea to be the one picked at the end of the week. So we try to work really hard to say we're all in this together, right? And we're trying to get the value for the company. But absolutely, right? So there's, again, different sets of skills. The guy who has the greatest technical idea may not have the foggiest idea how to run a project, right? And how to manage a project, or they've never done that before. So we can team up with someone to help them with that. So absolutely, that's sort of fundamental to the management process. And the best I can say is, the way I think about it, my job is to make them successful, right? So, and I can do that by reaching out across the company, finding other experts. Have you talked to these guys? They can advise you. They can consult with you. Have you gone over here? So they're not just sort of thrown in it by themselves. Me and my staff are there sort of as the advisors. So it's a little bit of a VC flavor, right? But we're there with a little bit of money, but also with the technical and network and know-how to help them be successful. But there's definitely cases where people just don't want to let go, right? Whether it's successful or not, right? Their idea is the best idea. And we just don't understand it yet. So
that would happen with DARPA PMs too.
Yeah. Got to keep going back.
So please join me in thanking John. So I do have a parting gift for you. Since you're not a government employee anymore, I can't use the nominal value.
Yeah, it's got to be
joke,
something really good.
Yeah, but it's still something. It's something.
It's not orange. So is that a hokey color, or I'm not sure?
Close enough.
Okay. Yeah. The ribbon is.
So please, everyone, thank you for joining us.
Thank you.
The reception will continue until there's no one left standing. So please join us. I think the conversation can continue. If you had a question that you wanted to ask, but we ran out of time, please grab John. And thank you again for coming, and see you at the next one. Thanks everyone.